Okay, gonna make a couple videos on nomenclature for ACS. I would expect between probably 4 to 6, or maybe probably 3 to 6 questions on nomenclature for ACS. I would guess out of the 70, maybe probably not more than 7. With those, these highest priority groups, which is gonna be this first video, are the least important. They might not even show up at all. The most likely of them are listed here. I'm using, if you want to, it's a masterorganicchemistry.com is where I'm getting this from. They list 5 of these carboxyl derivatives. The sulfonate groups, the sulfonic acid and acid halide, just not even going to touch on. It's just so unlikely that those are going to be tested on nomenclature rather than something else. And even these, highly unlikely, but just enough to where we should be aware of them in case one of them does show up. It will be a case where you don't need to fully memorize, on how to name every single acid derivative. Because it's multiple choice, process of elimination is definitely going to help. And that goes with all nomenclature stuff. So here listed, I have carboxylic acids, esters, and amides. These are the only 3 acid derivatives that we're going to be worried about. And carboxylic acid is going to be the most important. If any of them are going to show up, it's going to be this one, then maybe esters, then maybe amides. Because these are the highest priority groups, they're likely also not going to be seen together, meaning we really only need to be worried about the suffix in the root name. We would only use the prefix if we have a higher priority group that's taking that place. So what I would only use aminocarbonyl prefix if I had something else higher priority taking the root, such as an ester or carboxylic acid. Since that's such a low chance of experiencing 2 of these carboxylic acid derivatives together, we are just going to only worry about the suffixes, okay? We're going to go with the 99% chance that there's only going to be a suffix involved and the 5% chance that we even see one of these things. So don't worry about the prefixes necessarily. I think I may do an example or 2 down here where we use the prefixes, but I would only really focus on the suffixes, 9 times out of 10. There's only going to be one of these on our molecule to name. So with carboxylic acid, again, it's the highest priority. It's the functional group we're going to use all the time. So we're going to use suffixes for that only. It's going to take our root. It's going to be priority, and also it's going to be carbon number 1. It's going to be carbon number 1, or the lowest. Well, yeah, it has to be a terminal end, so it always has to be carbon number 1. Here I have a familiar compound. Hopefully, we take the carbon chain, we put oic acid at the end of it, and that's all we do. Carbon chain, oic acid. That's how we name carboxylic acids. Carbon chain, oic acid. My carbon chain here, what is this group called? This is a benzene group. So carbon chain, oic acid. This is benzoic acid. Simple enough. We've seen that before. Benzene, benz is my, I'm not going to say benzene oic. I'm not going to go 2 vowels in a row. Benzene oic acid. Benzoic acid, not benzene oic acid wouldn't even be a choice. So we're good on that. Benzoic acid here. How about try this one? Carbon chain, 3 carbons, oic acid. What would this one be called? This one would be propanoic acid. I have 3 carbons. My carbon chain is propane, carbon chain, oic acid. Propanoic acid. There we go. And again, those are always going to be carbon 1. So carbon number 1 in this case, right here, and I would number this way. If I had other substituents on there, I can go, maybe I have a an alcohol on number 2. I could say 2-hydroxy propanoic acid. And get all my prefixes out here, because my root, my highest priority, is going to be carboxylic acid. Or, yeah, carboxylic acid group. In this case, propanoic acid. Carboxylic acids, we're ending in oic acid. We're going to end, we'll get to esters now. Esters are going to end in O8. There's 2 sides to an ester. There's the carboxyl side, and then there's the, what I'll call the ester side. Okay, there's one chain with our carbonyl group, and one chain with our ester group. So we can say this is our carbonyl group, and we'll say this is our ester group. When naming esters, we're going to first name the ester group, and then finish with our carboxylic group. I'll show you how that works, and then we can try this one, or you can try it on your own. We're first going to name the ester group. In this case, I have 2 carbons. What kind of group would we call this? Just 2 carbons. This would be an ethyl group. So we're going to start with ethyl to describe our ester group. And then we have to take our carbon chain of our carboxylic group and end it with O8. O8 is going to tell us we're dealing with an ester, and these other words are going to tell us on how many carbons are on either side of our ester. So our ester group, we said was an ethyl group. What is our carboxylic group with 3 carbons? Propane, right? Now take propane and put O8 on that, propanoate. This is called ethyl propanoate. First, I described the ester group. I said this was an ethyl group, and I said this was a propyl group. So ethyl propanoate. Ethyl propanoate. Okay? Ethyl group, propane group, O8 is telling we have an ester. And again, this would be carbon 1, our carboxylic carbon there. Carboxy carbon. That's going to be carbon number 1. And then we would number going this way. 1, 2, 3, and so on. Our ethyl group is treated as its own substituent here, just sticking off of our ester. Don't expect there to be substituents on both sides. Hardly don't even expect there to be esters or any of this stuff on there. Again, this is probably the least important nomenclature, but being just familiar with it, watching the videos is going to help in case it does show up. Maybe retrieve something if they show up on ACS. Go ahead and try this one on your own, okay? Now, well, I'll get into that in a bit. Try it on your own. There's a couple names you can call this because some chemists thought it would be neat if they made it more difficult and had special names for certain smaller groups, but we don't really need to do that. IUPAC, we can use traditional naming for this. Try it on your own. What group is our ester group? What is our carboxy group? And then how do we finish it off with our root? There's my ester group. My carboxylate group is only 1 carbon. So I'll start with the ester group. I have a methyl group, so we would say this is methyl all one word. Methyl, and this is also a methane group, right? Just one carbon, so methyl methanoate. Methanoate. All right, that's perfectly acceptable. And going by the rules, that's what we would call it, methyl methanoate. It sounds a little funky. When you have one carbon acid derivative, such as, oh, right here, these two on the bottom, instead of methane, you might see formic acid, or you might see formate. Instead of methanoate, you might see formate. Or instead of methanoic acid, you might see formic acid. Both of them are acceptable. I don't know if the ACS prioritizes common names or IUPAC names. I think IUPAC in that case. But you've heard of formic acid, you've heard of acetic acid before, they're used all the time. But acetic acid, if you look closely, is the same as saying ethanoic acid. It's an ethane group, 2 carbons. So is they mean the same thing. Instead of ethanoate, you might see acetate. They mean the same thing. So formic, same as methane, and then acetic is the same as ethane. Formic 1, acetyl 2, there are more and more, but those are our main ones. So instead of maybe just saying methyl methanoate, we could say methyl formate. Mean the same thing. This is perfectly acceptable. Lastly, we'll get into amides. We're not going to talk about sulfonic acids. We're not going to talk about halides. Those are included in masteringorganicchemistry.com. Those are just, you're not going to have to name those. Not going to have to. Let's actually, well, I don't even want to do these. I'll name them, but they're really not that important. We won't, you guys shouldn't have to do this, but carboxylic acid is going to be our highest priority, okay? And then we would name down the line. I look at this one on the left. My ester group has become a prefix. So I would say this is, our alkoxy group is methyl. So I would say methyl carbonyl. 1, 2, 3, 4. 3. If you really want to know, this is not important. This would be 4 methyl carbonyl and then we have 1, 2, 3, 4 carbons, so we would say this is butanoic acid. I don't know why I changed. 4 methyl carbonyl butanoic acid. Where now the ester has become its own prefix because it had a greater priority group, the carboxylic acid, taking the root oic acid part. Similar thing here. 3 ethyl carbonyl propanoic acid. That's if you had to combine these. You won't have to do that. I really don't think you're going to have to do that. There's some examples of them combining them in that website, but ACS should not go in that much detail. Now we'll do amides, just amides, and they're going to be very similar to esters. Okay, did I write any? Oh, they're down here. So I have 2 amides listed. The suffix is going to be, look at that, amide. Isn't that nice? Okay, with this first one, I don't have anything over to the right. I just have hydrogens. I don't have any carbon chain. That would usually come first, just like our ester groups came first when naming esters. And we'll get into that over here. But right now, all we have are just 2 carbons, and we have a reduced amide. Fully reduced amide, 2 carbons. 2 carbons, what group would that be? That would be an ethyl group. And my root is amide. This is ethylamide. Okay, over here I do have a chain. I have a chain on the right. So when we had those with esters, right, those came first. Our ester groups came first. So here I would have methyl group. Methyl. And we just said what this group was, right? 2 carbons. That would be ethylamide. Ethylamide. If that doesn't make sense, don't sweat it. Very unlikely that these are going to show up. But just being familiar, watching this video once, trying them, okay, is in the one case that you might get one question, you know, that could, maybe that's a 47 out of 70 instead of 46, okay? Just in case they show up, don't practice these. Watch this video, maybe watch it again, maybe, tops. Probably not gonna show up. Spend your time doing more important things like the next video I'm gonna make, where we go down with lower priority groups and functional groups, alkynes, alkenes, alkanes, alcohols, ketones, aldehydes, so on. Don't be intimidated if this does not make sense. It was really never covered in class. I haven't talked about it before, but like I said, worry more about the upcoming videos.